Okay, so welcome back to another video, and in this lesson we're going to deal with contingency tables for chapter 11.2. Okay, so what is the deal with this? What are we dealing with? I'm going to tell you this. We're going to be dealing with tables, and in the calculator, these are also considered matrices, so we're going to get familiar with that terminology. As a precursor, we're going to be dealing with the significance level stuff a lot. Just like in the last, the last chapters, and let's just jump right in. So, they're talking about the ability of dogs of using their extraordinary sense of smell to detect malaria in samples of children's socks. It says we have an accompanying information that shows the TI 83 and 84, which is what we're going to be doing a lot. So, let's go right to it. Okay, so here's what the TI 84 is going to show. We're going to be finding those as well. And let's just go ahead and put the answers in. So, what is the test statistic? 2 decimal places, that is 19.49. So 19.49. So just like in the other chapters, we're going to have a test statistic. We're going to have a p-value going on. All right, what is the p-value? So you can see I worked out the p-value earlier. The p-value, they give us 1.0115. We have e-5, so we're going to take that decimal and move 5 places to your left. So 1, 2, 3, 4, 5. Every loop that you make will get a 0. And so now we're here. So that's really 0.0000101. And it says to round to 3 decimal places. I'm just tongue-tied tonight. I don't know what's going on. All right, anyway, so here's the 3rd decimal place right here that's underlined. We glance over to the right. It's another smiley face, by the way. And when you round it, it is just a 0. So the p-value here is going to be 0. Now, did you notice they didn't give us a significance level to test against? And that's okay. Maybe they want us to always test a specific significance level. Maybe it'll never change. We'll search that later. A little tidbit. These programs are not really 100% helpful to us. They expect us to figure everything out on our own. As you can see from the meltdown from my last video, the last few minutes, that was fun to watch. All right, anyway, state the conclusion. Okay, so our p-value is 0. 0 is always going to be less than whatever standard, whatever sig level that they have. So this is going to be a reject. And so look at the terminology. So we know it's reject, but look, they have hypothesis of independence. So reject the hypothesis of independence or the hypothesis of dependence. Which one is it? Well, I will tell you this. Your HO, your null hypothesis, will always include independence. But it's like independence of what? It's independence of your rows and your columns. So just a little refresher. Rows go from left to right. So right where it says dog was correct, the 123 and the 131 are part of the dog was correct row because it's going left and right. The dog was wrong. That is the dog was wrong row, which is going left and right. And let's go up and down. We have malaria was present. That is a column. And malaria was not present is also a column. So this particular table here has 2 rows and 2 columns. So your null hypothesis is in terms of the relationship between the rows and columns. You're always going to say that your null hypothesis is independence of the 2 rows. So the 2 rows are independent of each other. So let's take a look at the actual terminology. So H sub 0 in this word form, it says whether a dog makes a correct identification. So the identification portion is whether the dog was wrong or correct. So that's the row category. And we want to see, we want to state that it's independent of the column category, which is whether malaria is there or not. So malaria is present or not. So your HO will always be the row independent of the column or vice versa. So very similar to what we had before, but with a twist. Okay, so we're going to reject the null hypothesis of independence. Null hypothesis is always going to have independence in it. So yeah, there we go. All right, well done. Does rejection of the null hypothesis of independence imply that dogs are good at identifying malaria? So we rejected the null hypothesis, which means that we're saying that the alternative hypothesis, the H1, is the one that we should be following. That's the true one. So we're supporting the claim that whether a dog makes a correct identification and whether malaria is present are dependent upon each other. So, So does rejection of the null hypothesis of independence imply that dogs are good at identifying malaria? Like, the answer is no. Okay. The answer is just no. And it's because, yeah, you see it. If you get this question, just choose no, and it's possible that the dogs are wrong significantly more than they are correct. But yeah, like just choose that one. Okay. These other sidebar, insightful questions are, I don't think they're really teaching much, but that's just my opinion. Yeah, you just want to get an A, so choose that one if you see it again. You know how lame statistics can get. I'm keeping it 100 here. All right, anyway. All right, so question 2. Determine the null and alternative hypothesis. So the null will always have the word independent inside of it. So this HO, which is the null, says whether a subject lies in it. All right, hey, that could be it. Looks like that's the only one saying that the HO is talking about independency. That says not independent. We don't want the not version. We want the is version, the is independent version. So it has to be that one, even without reading the other ones. So yeah, for the null hypothesis and alternative hypothesis terminology, we want to say that HO is always is dependent, and that H1 is the not independent. And remember, for it to not be independent means that it's dependent, right? It means that the columns and rows are dependent upon each other. All right, anyway, let's keep going. What is the test statistic? So let's go here. Now, take a look. We are actually gonna go ahead and we're gonna input this whole table here, and we're gonna put it in the form of a matrix. A matrix is just a fancy way of saying table. Okay, that's what the eggheads in mathematics, that's what the smart guys started to call it. And you know, I plan on being one of those guys someday soon too, but they just use big words for no reason, like the word algorithm. Like if you wanna know if a guy is trying to sound really smart, he uses the word algorithm a lot. Also, the word caveat. If you want to know if you want to know if a person is a douchebag, they're going to use the word caveat. So it's one of those. It's one of those. I'm pretty sure you know a few as well. Anyway, let's go over to second matrix. And basically, we're going to create our own matrix. You want to go over to where it says edit, and we're going to choose choice A. We're only going to use choice A here for the remainder of this section. And now they're asking us how many columns, how many rows, and how many columns are we going to input. So this is a 2 by 2. Remember, we have the 11, the 26, the 29, the 14. That is 2 rows. So it's always rows times column. So how many rows? This is 2 rows. So remember, the rows run left and right. And then we have 2 columns. And take a look. Now we have 4 numbers to input, and all we do is put those numbers in. So 11, 29, 26, 14. Okay, we're done with that. Let's go ahead and hit second quit. We're going to go to, and yeah, there is a function for this. We're going to go to stat. We're going to go to tests. And we're going to hit the up arrow because the chi-square test is all the way down here, is letter C. So yeah, chi-square test. Okay, so everything is already laid out for us. This is read as matrix A. It says observed. This is matrix A that's being observed. The expected, they're going to create the expected for us. And, it's great for us that, we're using technology so we don't have to use the mathematical computations in order to find that. It's already done for us. Just go straight down to calculate, hit enter, and there goes our test statistic and our p-value. So we're ready to roll. Let's go ahead and exit from here. Let's hit done. And yeah, so test statistic, 3 decimal places, so that's 11.314. Excellent. What is the p-value? P-value is going to be 7.69. 4 decimals to your left. They wanted 4 decimal places, so just to be extra cautious, I like to just write them down. So let's go ahead and take away the calculator for a second. I like to write them down. Yeah, even me. I like to write them down and move step by step according to the number of decimal places. All right, so let's see what that is again. So our p-value is going to be 7. Let me choose the pencil. 7.6939.826 e minus 4. So we take the decimal here, we move 4 places to our left. So 1, 2, 3, 4. Every single loop gets a 0. So we really have 0.0076939.826. So here's what we have. They want us to round to 4 decimal places. So we're going to stop here, but we're going to glance at the number to the right. If it's 5 or more, we're going to add 1 to it. And it is 5 or more, so we're going to add 1 to it. So this is 0.000. Add 1 to it, 8. So we get 0.0008. So let's go to there right quick. So 0.0008. Excellent. Now our p-value. Now you see how now they're giving us a sig level to work with, right? And our p-value, just like in the last chapters, our p-value is definitely less than our significance level. So because of that, we are going to reject. Now they're not asking us for a rejection in this case. They just want the second part that comes with it. So we're going to reject. And remember that whenever you reject, there is enough evidence to support the claim of, oh, they're using warrant rejection. So that means, what is this supposed to be technically a two-tail? Okay. There is sufficient evidence to warrant the rejection of the claim that the polygraph didn't. No, I don't think that's what we're dealing with. We're talking about independency. We're going to, let's see, there is sufficient evidence to warrant rejection of the claim that whether a subject lies is independent. Yeah, that's more like it. We want that word independent in there somewhere. Nice work. And to the next one. Okay. In a study of high school students, this is question number 3. In a study of high school students at least 16 years of age, researchers, whatever. Okay, so take a look. We have another table here. Let's take care of the small stuff first since we're here. Determine the null and alternative hypotheses. So that HO better have the word independent in it. And it better be talking about the 2 categories. So it's not that one. They're saying dependent. This is independent, but so does that one. So, which one do we use? We're not going to use the top one. It has the word dependent. So which one do we use? Now, the one that you use is what closely resembles the row and the column of your table. So this says texting while driving is independent of driving while drinking alcohol. Well, let's see what they have here. We have texting while driving and not texting while driving. So that's the row category, whether they're texting or not. That's the row category. The column category, which goes up and down, is whether or not they were driving while drinking alcohol. So let's find the one that closely resembles that. Yeah, it's definitely this one. Texting while driving. So that's this portion, texting while driving or not. Or drinking alcohol, right? So that's what we're going to choose. This says all other risky behaviors. Driving when drinking alcohol? No, son. All right. H1 would be the opposite of this, but the same terminology, but we're going to use the word dependent. So it's either going to be this one or that one. And we want to use the same categories we used before. This is texting while driving and drinking alcohol. Yeah, those are the 2 specific categories for this one. And Yeah, I know we're going to get this right. Yeah, well done, well done. All right, test statistic. Okay, so let's go click on this table here, and we're going to put that whole table instead of our calculator. Let's activate the calculator. Bam. All right, let's open it up. So very slowly. I don't think I moved slowly the last time. I'll move slowly this time. Okay, so second, we hit the matrix button. We're going to move over 2 places to your right so we can highlight edit. So very similar to the stats edit thing where we put a list in, we're going to put a table in now. We're going to hit enter. It's still a 2x2, right? And let's just put our new numbers in. So we have 748. Sorry, 1 second. Okay, 748. There we go. Okay, 748. We have 3063. We have 152. And then we have 4493. Okay, so we have everything we need. Let's hit second quit. We're going to go to stat, tests. Let's hit the up arrow so we can reach the key square test option much quicker. Hit enter. Everything is already set up for you. Hit calculate. Bam. Okay, so the test statistic is going to be how many decimals? 2 decimals, 588.79. Got it. P-value, 0. So yeah, you know we're going to reject. All right, so we're definitely going to reject. So it's not going to be A, it's not going to be B. This says reject the null, but look at that other nonsense that 95% of the time. No. This is what we came here for. The word independence. Yeah, good stuff, good stuff. All right, next question. I like it when things work. Isn't it nice? Okay, we're going to go ahead and do this from scratch. So, but before I do it, let's memorize it. There is sufficient evidence. Okay. Had to cheat a little bit. Okay, let's go ahead and look at this table here. Determine a null and alternative hypothesis. Well, let's see the categories. We want to look for the word independent for the HO. So there's one. We're not going to choose that one. There's one. No, we need the word independent. And here's another one. Oh, it says not independent. So automatically, yeah, we're choosing that. We don't want to use the word not independent. Not independent means dependent. We want it to be independent or is independent. Okay, anyway, test statistic. Let's get our hands on that. Look at that, another table. What can go wrong, right? The only thing that can go wrong is if they ask us something crazy like, what does the data suggest about the blah 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 blah? Like, does not just suck. Anyway, second matrix. We're gonna go to edit. It's already a 2x2. It's ready to go. So 419, 54. 546, 18. We can hit second quit now. Let's go to stats, go over to tests, key square, test, go all the way down, enter, bam, there it is. So the test statistic is 26.3 decimals, 936, so 936. Good job. P-value is going to be, yeah, that's 7 places over to your left. So if it's 7 places to your left, it's going to be 0. Okay. So our p-value is less than our significance level, which is right up here. So the p-value is going to be, yeah, the p-value is less. So we're going to reject. When you reject, there is enough evidence. Enough evidence of what? So there is sufficient evidence to warrant rejection of the claim that the sentence, I like that one. They're talking about independent. Let's see. There is sufficient evidence to warrant rejection. Oh, they both say the same thing, except for the last part. The results do not encourage pleas for guilty defendants. Now they're going to make us think, does it encourage pleas for guilty defendants or not? Let's look at let's look at this. So we have 2 categories. Either they're going to accept the guilty plea or not, or they're going to be sent to prison or not. So we're testing if they have no, if there's no distinction between the two. So we just figured out that they are dependent upon each other. So, let's just see. Yeah, it's that one. We just found out that, yeah, they made the distinction that depending on if they are guilty, they're going to take the plea. Like they're relying on each other. So, this is one of those questions where you just want to memorize it and just get on with your life. And yeah, that's the answer. So yeah. I guess you can make some sense of it. I'm just the math guy here. Anyway, the accompanying, try to say that fast, table shows results of challenged referee calls in a major tennis tournament. All right, use a 0.05 sig level, blah, blah, blah. Let's see that data. Anything crazy? No, everything is still 2x2. Let's go ahead and at least answer this portion here. So once again, we have the H sub 0. We want to look for the word independent, and we want to talk about them being independent in terms of the rows and the columns. So you can see one row says men and women. That is pertaining to gender, right? Up here it says, was the challenge to the call successful? So we want to figure out, we want to make sure that when we choose our null hypothesis and alternative hypothesis terminology and verbiage or whatever you want to call it, we want to make sure it's compliant with these. So gender is definitely one of the categories. So the gender of the tennis player, yep, so that's the row, is independent of whether a call is overturned or not. So yeah, was a challenge to the call successful? That is what they call overturning. See, they're just using, if you're not really great with the English language, then it's kind of hard to follow, and I kind of hate that. But yeah, that's the idea here. So it was either going to be, yeah, it looks like C was the only one that it could have been, because they use the word independent. They're saying they're specifying that the column is independent of the row, and vice versa. The row is also independent of the column. So H1 has to say that they are not independent of each other. So anyway, let's go ahead and get our hands on the test statistic. So once again, we're going to go over to let's go to the TI-84. So stats, tests, we're going to go to chi-square tests. Oh, I didn't even put the matrix in. Stat, oh, I just want to hit that stat button so bad. All right, second matrix. We're going to go over to edit. We're going to hit enter. It's already a 2x2, so we're ready to go. Let me just look at something right quick. Okay, so 399, hit enter. 906, enter. 418, enter. 565, enter. All right, we are ready to rock. Hit second quit. Let's hit stats, go over to tests, chi-square tests, calculate, bam. All right, so 34 point. Listen, I don't claim to know mathematics. I only claim to be clever at mathematics. That's a difference. I can get by. Hopefully you get by too. All right, well done. Okay, p-value is going to be 9 decimal places to your left. That's 0. That's a very, very small number. Okay, so is there or is there not? Our p-value is once again 0, so it's definitely going to be less than our significance level here. So that's going to be a reject. And whenever you reject, there is enough evidence. So it's either going to be A or C, right? So, so we're going to reject the HO. So we're not going to say that they're independent. We're going to say that they're not independent. So we reject the null. So that means that we accept the alternative, and the alternative is H1. So let's see, there is sufficient evidence to support to warrant rejection of the claim that the gender is in the, yeah, that's got to be it. I like that one. Did they use the word independent or dependent? Nope. It's got to be that one. There's no way. There's just no way. All right, next. We're just breezing through these, right? All right, here we go again. Let's see. The accompanying table describes the whatever 0.01 sig level. Yeah, you know what time it is. Okay, look, we have a little bit more, and that's all they did. They just increased the number of columns. Very quickly. What is your HO? Your HO, you have to use the word independent. And what are the two categories? Let's take a look. As soon as they talk about male and female, that's gender. So that's the first category over here on your left. And all of these, look at the subject matter. These are eye colors. What is your favorite eye color on a love interest? Mine is definitely brown. Something about that brown, it just shines in the light. I don't know. It hits different. Like that brown eye color just changes. It looks like a jewel. You find a person with nice, pretty brown eyes, you better keep them in your pocket. All right. Anyway, okay. Let's go ahead and go to matrix. So second matrix. Edit, hit enter. Okay, so we're gonna go to 350. Oh, where are my manners? We have to put the number of columns. So the number of rows is 2. Remember, they ask you for the number of rows first, and then the number of columns is going to be 4 because we have 4 different eye colors. And watch this; they give us more boxes to fill in, so it's okay. 350. Make sure you're hitting enter as you're putting these in. So 296, 101, 163, 360, 340, 195, 182. Okay, hit second quit. You know what time it is. Stats, test, key square, enter, go down to calculate, bam, there we go. Okay, what is your test statistic? Your test statistic is 20.2 decimals, 1919. Excelente. Let's see, determine the p-value. They wanted 3 decimal places, so be careful with this one. Yeah, it's a little too close to home. I'm not going to just call it 0. I want to actually go ahead and write this thing down just so that I'm extra careful, and I want you to write it down each and every time too. Just take your time and move that many decimal places to your left, okay? So let's just erase this old stuff that we had here. All right, let me make sure you guys can even see that. Yeah, you can see. Okay, so we have 1.5506522 e minus 4. We're going to move 4 places to your left. So 1, 2, 3, 4. We're going to put zeros in here. And so we really have 0.00015506522. And now they want you to round to 3 decimal places. So we're going to round here. We glance over here and darn it, it's a 0 again because 1 is less than 5. So we're not going to add 1 to it. We're going to keep it as a 0. Anyway, well, it's always good to make sure that we know that we know. Anyways, let's just put a 0 inside of here. Give me 1 second. Multiple screens here. Fantastic. If you were to see my screen, you'd be like, how the heck are you navigating across this whole thing? Like, you must be losing your mind. Yeah, I've already lost my mind so long ago. Okay, use a 0.01 sig level to assess the claim. Our p-value is less than our sig, so we're going to reject. So it's either going to be C or D. We need to look for the word independent. Oh, no, there is. All right, so reject, and there, yeah, these are the only ones that can work, because whenever you reject, there is. When you reject, no, we're not going to choose that one. Those don't even go. Those will even go together. So they made this one a little bit simpler for us. Okay, so I'm going to go ahead and how about I start this over from scratch so you guys can see where I'm coming from. Okay, so what do we have here? Well, they gave us a nice little table. You know, it shouldn't be too difficult. On the left, we have gender, male and female. That's the gender category. Human activity, natural patterns, don't know. Well, let's see the subject matter. You know, we can cheat. We can go down here and see what they're talking about. Cause of global warming. Yeah. Select the cause of global warming. So it's one of those three. So that's the other category. So you see how I just nitpick and just find what I need and just get the heck out? Okay, so the null hypothesis, your HO. Let's see. Identify the null and alternative. So the sex of the respondent. Ooh, they didn't use the word gender. They used the PG word sex. Ooh. So we're gonna choose that for both. So gender, sex of the respondent. I'm so immature. Sex of the respondent is male or female. So yeah, that's the first one. What's the other category? The other category is the choice for the cause of global warming, and we're going to use that for both of them, both the HO and the H1. The top is always independent, and the bottom is always dependent. If they had given us this from the let's get it right first of all. Yeah, if they had given us this from the beginning, this is a nice little interactive way of figuring out which from which. Test statistic. Okay, ready? You know what time it is. We're going to go to the TI-84. Let's activate that for you guys. I'm getting better and better at this navigation as I do more and more videos. And thank you so much for watching if you're up at this point. Anyway, let's go ahead and put in our matrix. Okay, this is a 2x3, so let's go ahead and put a 3 here. Okay, so let's put in our numbers. 329. We have 132. We have 45. We have 307. 153. And 44. All right, hit second quit. It's very important that you hit second quit whenever you put in a list so that there's no tomfoolery or any nonsense going on or shenanigans or, as Mr. Mackey says, skylarkings. Anyway, shout out to South Park. Okay, key square test. Skylarkings. All right, there we go. So test statistic is going to be 3 decimal places, so 2.316. Okay. Critical values. Bum, bum, bum. Bum, 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 bum. They never asked us for critical values, but fear not, we can get it. Now, the sad part is, you know, don't freak out. There is no function in the calculator to figure out critical values. It's like, man, I paid $100 something for this expensive calculator and they don't even have a function for this. And you remember back in the day, back in the good old chapters of chapter 6 and 7 and 8, we hit second vars and go down to maybe inverse norm or inverse t. We just call it a wrap, put the area in, and we're done. It's not going to be so simple this time. But well, you know what? It is going to be simple, but there is no calculator for it. There is no inverse chi square. I don't know what the issue is. Why couldn't they put it here? Maybe if you have an updated calculator higher than TI-84 plus, maybe you do have one. And if you do, please put it in the comment section of the video so you can help out the other students. But this calculator does not. I don't think most of the TI-84s don't. Anyway, so how do we find the critical value? Well, we're going to have to do just a little bit of digging, and we're going to use this little fancy table right here. So we're going to have to get our hands on the degrees of freedom. And it's not too bad of a computation, I promise. We're going to get our degrees of freedom, and we're going to line it up with our significance level, and that'll be it. One thing I didn't say before, the chi-square histogram. I don't even know if I can consider that a histogram, but let's say the chi-square representation, the graphical representation is it's a skew. So I'm going to draw that for you guys so that you can get a better understanding, so you can get some idea of what's going on here. Let's go ahead and erase this other stuff. Hit minus. Yeah, there we go. Okay, so let me show you guys what I mean. So Let's make an XY axis first of all. And we have this in the other direction like that. So here's how a chi-square looks like. It starts low, goes really high, and then comes down just like that. And you have a little shaded region over here that's going to represent the critical value in your test statistic. It's going to be somewhere over here to your right more often than not. And in this case, this is considered a right tail test. So we can treat it as a right tail test. I've seen in the book that they also have a left tail technically over here somewhere. But you know what? We're just going to focus on our right. We want to keep it simple. That's what my channel is about. Keeping it simple, not going too far into detail. We're going to go ahead and put the the significance level there. And that's going to be 0.05. So that's what this is, 0.05. This is your alpha, your significance level. Let me go ahead and write sig level here. Sig level. Hold on. Don't want to close the parentheses yet. Sig level. That parentheses is very important where you open and close it, right? Okay, so let's go back to our table. And we're just going to reference that counter reference. So, degrees of freedom. Before I get too carried away, it's like, how in the heck do we find the degrees of freedom for this? Well, there's a little formula, a little mini formula. So let's put df is equal to, it's going to be your rows minus 1 in parentheses times your columns minus 1. That's it. That's it. So let's keep it going. It's like, what does it represent? It represents the number of rows and the number of columns. So how many rows do we have in here? We have 2 rows. So it's going to be 2 minus 1, close parentheses. How many columns do we have? We have, let me move down. We have 3 columns, right? 3 different categories for your columns. So that's going to be 3 minus 1. So remember, in the first parentheses, we have 2 minus 1, which is 1. Second parentheses, we have 3 minus 1, which is 2. Multiply them together, you get your degree of freedom is equal to 2. So we have our degrees of freedom. Not too bad, right? So, you know, jot this down in your notes because there's no calculator function for this. So you want to write this down. Write down the formula. Degrees of freedom is equal to open parentheses, your number of rows minus 1, close parentheses, open parentheses, number of columns minus 1. You multiply, you solve the inside. 2 minus 1, which is 1. 3 minus 1, which is 2. You multiply the results, you get a 2. So write that down, please do. Okay, so our degrees of freedom is 2. We're going to go to the significance level, which is 0.05. So that's right here. So remember, here's the second row. It's kind of hard to navigate with the mouse. Just remember it's the second row. And we want to go to 0.05. So 5.991. 5.991. Fantastic. I still got it. What do you know? Let's make sure you get it too. Okay, what is the conclusion? Okay, now the funny thing about this is that they want us to do the traditional method. When we found the critical value, the 5.991, we basically figured out what this guy here is. This is 5.991. And this is a chi-square right here, right? A chi-square has like a longer leg for what we call an x, like something like that. Where is our test statistic? What was our test statistic? Our test statistic was 2.316. Where would that go with respect to 5.991? Wouldn't that be somewhere right here? So that'll be our test statistic. That'll be the 2.316. Remember what we call this, guys? We call this the rejection region. So if our test statistic is inside of that rejection region, then we're going to reject the null. But our test statistic, which is way over here, the 2.316, is not inside of the rejection region, so we're going to fail to reject. Okay, so this is definitely going to be a fail to reject the null, which means that there is not enough evidence to support the claim. This last part, we're gonna guess on that. I don't even want to waste any brain cells thinking about that. But listen, let's say you wasn't too keen on using the traditional method here with the graphical representation. Hey, we can just go back to our calculator, go to stats, get our p-value, and do what we've been doing. Let's go all the way down to calculate. Our p-value is 0.314. That's definitely greater than our sig level, which is 0.05. Yeah, we already have it here, right? So look, even though they're not asking you for p-value, use the fact that you can get your hands on a p-value to your advantage. Okay, you're going to use that so many times in this course for the remainder of your course. So this is the p-value is definitely greater than your sig. So yeah, we're going to fail to reject. Whenever you fail to reject, there is not. And let's see if we can just get this right, just for the heck of it, just for kicks and giggles, right? To warn the rejection, blah, 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 blah. Men and women, like, I don't even know what this is about. There is not sufficient evidence to say that they're independent, so they are dependent. So, whatever. Clutch. Next. Let's go ahead. All in the guess. Just memorize that one, okay? Just memorize it. Just memorize the last part. Write it down. If you ever get to that I problem, just pick appear to agree. It rarely, I don't think it's ever going to change for you. Anyway, are you enjoying the video so far? Please like and subscribe and tell your friends, please. I appreciate you guys giving me such a high view count on these. Like, I have over almost 30 hours of view time. That's like 15 movies of Daniel, just watching Daniel do math. Like, that's insane. Thank you so much. And please refer to your friend. Please refer your friends to me. Okay. Anyway, so what is our null? Let's look at the subject matter here. We have car with rear plate only, car with front and rear plates. Looks like that's the position of the plate for our first category. Maybe they're going to use different words to describe it. I don't know. For the columns, we have California, Connecticut, New York. So those are going to be states. So for our null hypothesis, we're going to see if the position of the plates are independent of the states. So let's see if it's consistent with that. HO. Okay, I guess these are license plate laws. I should have read them. Yeah, it says license plate law. Yeah. Okay, so the license plate law determining whether you need the front and the back. I think in New York you do need the front and the rear. Yeah. Us in Florida, we only need the back because we're awesome. Anyway, yeah, same thing, license plate laws. That's for the rows. Remember, the rows is talking about license plates, position, license plate laws, I guess. Okay, it should be state. Identify, hold on, what's going on? Okay, looks like they have it in reverse. Yeah, they have it in reverse a little bit. So, and I only noticed that because we need something talking about states here, something that can describe New York, Connecticut, and California, and none of these do. So it looks like they reversed it. They're so sneaky. So we're doing columns versus rows this time, which, you know, like I always say, vice versa. It's okay. Over here would be whether a car has front or rear license plate. Yeah. They are talking about laws though. So laws, whether a car has front and rear. Whether a car has front and rear. I don't like the word and. Remember that and or type problem is either, sometimes it's either or. Either rear or front. Whatever. We're going to put laws followed. The top, the HO is always independent. Bottom is always dependent. If we get it wrong, it's not the end of the day. Remember, we're all learning here, right? Okay, it's not laws followed. It's the position of the plate. Whether a car has... forget them. Nice work. Okay, so you see, it's not the end of the world. We can get over this. We can do this. If you see this question again, you know which one to pick, right? Okay, let's look at the matrix. Okay, I don't see any funny business yet. we're still in part 2 of 4, so maybe they'll ask us later. Let's go to second matrix. Edit. Hit enter. This is a 2x3 again. All right, 34. 45. 8. 530. 285. 536. Second quit. Stat. We go over to test. We go over to key square test. And we go down to calculate. And there it is. So key square is gonna, oh, do you guys even see the calculator? No, you don't. It's there. You're just gonna have to trust me. Sorry about that. Right when I gave my props for knowing how to navigate this thing with 100% efficiency, then I don't show you guys a calculator. It's okay. Better late than never. 48. Fantastic. P-value. That's -12. That's a 0. We're going to move that place 12 places to your left. Okay, so the p-value is less than your sig, so you're going to, in the sig level is right here, 0.05. So you're going to reject the null. There is enough evidence to support the claim of independence. Yeah. I'm glad something is there before I even read it. Between a state and whether a car is it blank appears that the license plate laws are followed at the same rates of the 3 states. Okay, so we figured out that since we're going to reject the null, we're rejecting the HO statement. So we're going to accept the H1 statement. So they are dependent on one another, which makes sense. If they have a law set in place for you to do something, yeah, most people will follow that. Most law-abiding citizens. Let's see, that the license plate are followed the same. Look, I don't know. All right, it's not that one, so is this one. Like, I don't even memorize it. We are done. I have 100%, but we're not quite done with the subject matter yet. But look, I'll show you what this is all about. A blank is a table in which frequencies respond to 2 variables. Yeah, this is called a contingency table. That's what this whole chapter is named. So yeah, they also, let's see, a contingency table or a 2-way frequency table. That doesn't sound nice. It's a 2-way. It's a table in which frequencies correspond to 2 variables. Yeah, you know, like gender and weight or something like that. Anyway, memorize it. Okay, which of the following is not, okay. Let's hit try again. Okay, which of the following is not a requirement of conducting a hypothesis test for independence between the row variable and column variable in the contingency table? Okay, I will tell you this. One does not belong. It says the sample data are randomly selected. No, that is a requirement. No, in almost every instance of this course, you need to have your sample to be, it has to be randomly selected. Let's see, for every cell in the contingency table, the expected frequency E is at least 5. Yeah, now we didn't go over the expected frequency at all. I'm gonna show you where to find it though, which is not really necessary for this homework assignment, or I don't even think you have to figure it out for your tests, but basically you notice that there's a B here. Like you see, we have a B that's generated every time we hit stats and go to key square. It generates a B for us. And if you want to look at it, hit enter one more time. You get this. This is your expected, your E, your expected frequency. They actually fill it in for each of them. So I don't think, for those of you who are not taking this specific course, this will be helpful to you. That's the matrix that's generated, and those are the corresponding values for the rows and columns. As a rule of thumb, very similar to how we have to have our sample size as greater than 30 when we're dealing with the stuff from the previous chapters. They're really crazy about these expected frequencies being 5 or more. So that is a requirement. The last part, the sample data are represented as frequency counts in a 2-way table. Yeah, that's true. Look, this is the elephant in the room here. This doesn't belong, okay? Yeah, it's just not a requirement. That's it. I forgot what the O means. You have to forgive me. I'm pretty sure you stumble across it somewhere else. Okay, I'm not even gonna go from the beginning of here. Here's the answer. Small values of the test statistic reflect significant differences between observed. Yeah, that is not true. It's actually the opposite. Um, it actually reflects a larger value, like large values. Everything else is true. It says the number of degrees of freedom. Yeah, remember that we have to find the degrees of freedom in order to find the critical value. R is the number of rows. C is the number of columns. Yeah, that would be a requirement if we were doing everything by hand. The null hypothesis is the row and column variables are independent. Yeah, remember I made a big case about that. That's for the null hypothesis, your HO. They have to have the word independent, and they have to compare the row and column variables, the categories. And the tests of independence with the contingency table are always right tail. Yeah, especially by this little diagram here. Let me take this off. Yeah, remember we made that little right tail skew looking histogram thing, pseudo histogram thing. Yeah, it's always going to be right tail. So those are all true statements except for the small value portion. And mathematically, they go into that. Okay, thank you so much for your patience. Thank you much for watching. Please like, comment, and subscribe if you like. I appreciate all the likes. They destroyed the dislike button, so I don't know why would YouTube do that. It takes away the fun. Anyway, thank you so much for watching, and please do well on your exam, and you have a wonderful day.